Right. We're going to talk about ordering real numbers or classifying real numbers. Now, real numbers include the set of real numbers includes rational numbers and irrational numbers. Now, let's talk about the rational numbers here. Now, as we can see, rational numbers has integers, whole numbers, and counting numbers. Let's start from the basic. Let's start from the bottom right here. What is a counting numbers? Now, this is natural number. Natural, right? Natural numbers, right? Which is 1, 2, 3, 4, right, and so on and so forth, right? That's called natural number. We can count them. We call them counting numbers because we can count them like 1, 2, 3, 4. There is no decimal point, no decimal numbers, no square root, right? The perfect. There is a perfect square root. I mean, like square root of 4 is 2, so that's also called counting numbers. But there is no like square root of 5 or square root of 7, for example, right? The whole number is the same thing as natural number, the same thing as natural number, but we're gonna add zero. We're gonna add zero, right? That's called whole number. Integers, right? For the integers is the same thing as the whole number, right? Including zero. So it's the same thing as whole number, right? 1, 0, 1, 2, 3, 4, right? And you add the opposites of the natural numbers. The opposite of that, which is negative 1, negative 2, negative 3. So you go all the way to negative to the left right here. As you can see, negative 1 is opposite of 1. Negative 2 is opposite of 2, and so on and so forth, right? Now, this is called integers, right? All those like set of numbers, natural numbers, whole numbers, integers, are part of rational numbers, So let's go more details about what is rational number. What is rational number, right? What is rational number, right? So the rational numbers is a fraction, right? Beside rational number can includes like integers, like any integer is rational number. Any whole number is rational number, and any natural or constant number is a rational number, right? But also rational number, right? Rational number, right? Can be expressed as ratio of two integers, a over b, right? And a, right? A must be integer, and also b must be integer. Again, rational number is a number that can be expressed as a ratio or fraction in a form of a over b, and both a and b must be integers, right? And of course, b always different than 0. b different than 0, right? Well, let's get an example here. If I have, like, for example, 2 over 3. Now, 2 is integer and 3 is integer. So 2 over 3 is a fraction of two integers, 2 over 3, right? And also, what about 5? We know 5 is a natural number, is a whole number, an integer, right? But also 5 can be expressed as 5 over 1, right? So this can be expressed as rational number, right? What about negative 3? What about negative 3? Now, negative 3 can be expressed as ratio of negative 3 and 1, right? Negative 3 is integer, and 1 is integer. What about the square root? What about the square root of 25 over square root of 64, right? Now, we know the square root of 25 is 5, is a perfect square, right? And the square root of 64 is 8. Well, 5 and 8 are both integers, and therefore, this is expressed as rational number. One of the characteristics of rational number is terminating. right? Mean it stops at certain point, like 0.25, right? And it stops right there. We don't have like 4, 5, 1, 3, all the way to the end. No, it stops right there. It terminates exactly at 5. So this is also, all right, let me just write this one. This is also called like rational number. You know that 0.25 is a decimal point, can be expressed as ratio of 25 over 100. And as you can see, 25 is integer and 100 is integer, right? So that's also called rational number. Also, we have like 0.135. It stops right there, right? Right. Another characteristic, it's called repeating decimal. Repeating decimal, right? Like for example, if I have like 1.555 all the way to the end, as you can see, I have a pattern that's 5 repeating itself, and this one can be expressed as 1.5, and we put a sign, bar sign above 5. That indicates that 5 repeating itself forever, right? So the same number repeating itself. Sometimes we may have two numbers repeating itself, like 1.25, 25, 25. So as you can see, you have a pattern of 25 repeating itself, right? This is also can be written as 1.25, and you put a bar here. That indicates that 25 repeating itself, forever. The last thing I want to talk about is irrational. Now, irrational number is a number that cannot be expressed as a fraction with integer. And also, one of the characteristic of non-terminating is characteristic of irrational is non-terminating number. Like for example, if I have a square root of 2, if I have a square root of 2, no, if we use our calculator, the square root of 2 will give me like 1.41, I believe 42, 13, 5, and 6, and so on and so forth, right? So we have a different numbers we don't have a pattern of the same number repeating itself like rational number, right? So and it goes forever, right? So the rational number is expressed in decimal form, and it goes on forever without repeating the same number, right? So that's called irrational. As you know that the square root of 2 is not a perfect square, right? So like unlike if I have a square root of 4 or a square root of 9, that's 3, right? So 9 is a perfect square, so 3 is going to be rational, not irrational. So this is not irrational, right? So this is not irrational. What about pi, right? Pi, right? We know that pi is about 3.14, 15, 9, 2, 6, and so on and so forth, right? So again, this is not terminating, right? And then it doesn't stop. We don't have the same number repeating itself. So pi also can be expressed as irrational. Even if we multiply, for example, if you multiply any irrational with rational, it's gonna stay irrational. For example, let's suppose I have like 2, right? 2 times the square root of 7, right? Right? No square root of 7. No, 7 is not a perfect square, right? 7 is not a perfect square, so this is gonna stay irrational. It's gonna stay irrational. Right? We have like, for example, square root of 2. We know the square root of 2 is irrational. If you multiply by any integer or rational number, it's gonna stay. This is also irrational. It's also irrational. Why? Because the answer at the end will be irrational, right? Like for example, let's suppose I have like 3. Let's suppose I have like 3 plus square root of 2. Is it rational or irrational? Since square root of 2 is irrational, if you add it to any integer or rational number, it's going to stay irrational, right? And we can try this one here. Look at this. I have a square root of 2 is like, for example, 1.41, 42, and so on. If you add 3 here, it's going to stay irrational. 3 plus 1 is 4. This is like 4.41, 42, right? All the way to the end. So if you multiply any number, right? If you multiply any number except itself, by irrational is gonna stay irrational. And the last thing I want to, just I want to add to this one here. If I have a square root of 2, now if you multiply by the same number, right? Remember, this is gonna remove the radical is gonna be 2, and this one is gonna be irrational. Okay. So the only case that when you multiply number by itself, right? When you multiply irrational by itself, right, is gonna give me like rational number, right? But just keep in mind that square root of 2, pi, any integer not a perfect squared is gonna give me like irrational number. And here is a good summary to this. As we said before, again, natural number is a set of all counting numbers, right? Which is like 1, 2, 3, right? And then I have the whole number. You're gonna add 0 right here. So you're gonna add 0 to the natural number, will give me like the whole number. Then I have integer here, which includes all the natural number and the opposite of the natural numbers, which is negative values here, right? Plus 0, plus natural number. Then we have a rational number. It includes everything. It includes 0, 1, 2, 3, and -1, -2, -3, -4, and also the ratio of two integers. Like 9 is integer, 2 is integer, 7.12. This is the same thing as 7.12, 12 repeating itself, right? 11.23 is terminate, right? It's terminating number. 3/4 is a fraction or ratio of two integers. So this is called rational. Again, rational includes integers, whole, and natural numbers. Irrational numbers, it's different, which we have non-terminating values like 2.71, 8.2, and always go with whatever. Square root of 2, right, is an example of irrational. Then we have pi, also is example of irrational, right? You add any value to pi, is going to stay irrational, right? If you multiply any value, for example, to square root of 2, right? Except square root of 2 is going to give me like irrational number. All right, so I'll see you to the next video.